In this video we're using the Google Science Journal app and we're doing experiments using the compass to walk in a straight line. The two little screens you see here on screen are from my Moto G8 Plus using Android 9. So this should be quite fun actually, because, don't mind seeing that, we open up the Science Journal. What I've already done is recorded these experiments. So if you're brand new to Science Journal, when it opens up, you have normally got a, let's do it. If you open it up, everything's blank. If you click on the sensors, you can choose between a range of, so that's light, sound, different hertz, whatever that is, X's, Y's. If you go up and enable, I will disable that because the one we're going to use is the compass. So for an example, if I pulled that up full screen, I asked myself the question as a former science class teacher, amongst other things, is what would happen if I tried to walk in a straight line across the park? And at the moment I'm rotating the phone here and you can see that things are moving around, with the most fortunate thing, which is this G8 Plus does have a compass, and you can see the compass dial turning. So as I move, oh, let's turn that off a moment. We can get audible ideas that we're walking a straight line. So maybe with the new school year coming, you can challenge your friends and things like that. So let's go to the results of how we did it. And that is that the image there, by the way, the image of the compass, is merely from my compass app. That's all it is. So I just wanted to put an image there. You can do an image of the site that you're working on or of any observations. I will share my results. So we open up the app where I have done 3 sets of experiments. Number 1 at the top here, I walked for 57 seconds in a straight line. Then I walked back. Then I walked in a little square, and quite honestly then I walked up the road trying to get in a straight line of 250 degrees, which actually worked really well, which is really bizarre. So let me show you how that works. So the first thing is that I stood in the park and I thought it would be really clever to try and walk at 0 or 360. How wrong I was. It just didn't work. So what you can do if you're new to this app is, once the results are in, let me just play. So obviously I'm not going to play the whole lot, but what's actually happening is you've got a big red button to record, which is at the bottom of, show you that again, let's be really thorough here. You can see that if I want to record my compass right now, I press the red button. So let's take that down and go back to these results. So what happened was that the first one, I walked at a straight line dead on 0 or 360, and it just was terrible, because what happened is, as you can see on the bottom, is my aim was to walk on a grass field at 0, but it was a very bad data set because 0 and 360 are too close together. So although I worked for 150 meters, the results were all over the place. Quite fun to look at, and I'm just zooming with my fingers here. Alright, let's just come out of that one to move a bit quicker. My challenge here for myself and anybody else is, how would you use the compass on a smartphone like this to actually record some really, really good data sets based on whatever your hypothesis for science or your question actually is. The next one was to walk at 180 degrees, so in other words back across the straight line across the open field. I did it and I averaged for some reason a minimum of 152, middle of 175, so not the 180, and a maximum of 202. My point is, I would imagine that if you got a bunch of children together and they all tried to walk in a dead straight line for like 1 minute, I wonder who could actually hold that phone or point themselves to that object perfectly. Really, really interesting. Now I was holding it in my hand. Maybe if you put it on a trolley or I don't know, something. Notice that the app is fantastic because you can copy this over to Google Sheets, or you can just move along and play at a very detailed level. You watch, if I put it there and play, everything plays back to you. Incredible. And then the last thing to move it along, oh, that one I'm not going to bother with. I tried to walk in a straight line, and yeah, it's quite fun to play back, you know, where you actually get into higher pitches as you walking in a square. And the one that I thought of, again, this is always the best, seems to come to at last, doesn't it? Weirdly weird, is that I walked up at 250 degree was my setting, along a pathway or a sidewalk on the side of a road for 250 metres that took me 151 seconds. In other words, it took me all the way along to 2.5 minutes. But here's the interesting thing, is that I'll show you in a second that the data points that are gathered in that time are 4,202 data entries in 151 seconds. That's actually 28 data recordings per second, which is pretty amazing, I think, really. And then, of course, I walked up, and the most weirdest thing is that as I walked, my minimum angle on the compass was 162, my max 303, but I averaged exactly on the 250. Now, the interesting thing, I was argue that data is not wrong, but being, primary school 7 to 11-year-old children, I used to teach this amongst other things. This data point here, which actually moves to my left a lot, I think I was avoiding one of those big garbage bins, and that's actually why I moved. Now, if that garbage bin hadn't have been there, so maybe repeat the experiment, then I would not have veered over to the left here at about less than 180 degrees, and therefore I wonder if I would have kept my average. That's pretty much it of an excitement of my afternoon going through. I could actually crop it, in other words the data, share it, download, which I'll demonstrate in 1 second. I can change all the audio settings if you're not sure about, or you're new to Science Journal. And what's the other thing I could do? I can enable an auto scale. What does that do then? As opposed to disabled. Sounds pretty much the same to me. Anyway, it does not matter. Now, what I can do, and this is the final thing, is if I get this and I wish to download, it offers me a relative time or a regular timestamp scale. I will save you the expense of that and go straight over to the sheet, and this is what is just incredible. The data set for that 2.5 minutes, and I can zoom right in. This is using Google Sheets app on the mobile, no need to go to a desktop. Go all the way to the bottom, and you can see that in that 2.5 minutes there is 4,202 data sets. The angle there, let's go back to the top. Whiz. If you are new to your school year and you want to impress yourself or impress your teacher or just learn generally, then how can we use that compass? Then I can go over to the chart, which again you can upload this to Drive and use it on desktop, and there is a chart of which I would argue is not as good as the other chart on the actual app. I think I can finish up here and say that was that one. In terms of the app, Sheets, wasn't it? My Google Science Journal experiments using the compass to walk in a straight line. And more importantly, that when you go to, and this is quite a big deal, is when you go to sciencejournalwithgoogle.com, you get all these incredible experiments. Now, I've not really found one, a decent one for the compass that I like, probably because there's not many there, but Science Journal is graduating out of Google, and it's going to Arduino. It's going to be graduating from Google and moving over to Arduino. So that is coming, I think, next month, which is about in September 2020. I can't say much about that at all, apart from have a read of that. I'll put a link in the box. So this again was me, Mike Downes, talking about Google Science Journal experiments using the compass to walk in a straight line. How would you use the compass? Once again, YouTube, Mike Downes.